Welcome you all. Today we are going to discuss an exercise in performance characteristics of road vehicle in vehicle dynamics. A vehicle weighs 20.02 kilonewton and has a wheelbase of 279.4 centimeter. The center of gravity is 127 centimeter behind the front axle and 50.8 centimeter above the ground level. The frontal area of the vehicle is 2.32 meter square and the aerodynamic drag coefficient is 0.45. The coefficient of rolling resistance is given by Fr is equal to 0.0136 plus 0.4 into 10 to the power minus 7 V square, where V is the speed of the vehicle in kilometer per hour. The rolling radius of the tire is 33 centimeter. The coefficient of road aeration is 0.8. Estimate the possible maximum speed of the vehicle on ground and a grade of 25% as determined by the maximum tractive effort that the tire road contact can support if the vehicle is A. rear wheel drive and B. front wheel drive. Plot the resultant resistance versus vehicle speed and show the maximum thrust of the vehicle with two types. In a given data, the weight of the vehicle W is equal to 20.02 kilonewton, that is equal to 20,020 Newton. Wheelbase L is equal to 2.794 meter and the distance between the front axle and center of gravity 1.27 meter. Height of the center of gravity 0.508. Area is equal to 2.32 meter square. Aerodynamic drag coefficient CD is equal to 0.45. Then rolling resistance coefficient Fr is equal to 0.0136 plus 0.4 into the V square. Rolling radius of the tire is equal to 0.33 meter. The coefficient of road adhesion is mu is equal to 0.8. Find the possible maximum speed of the vehicle on level ground and on a grade of 25% as determined by the maximum tractive effort that the tire contact can support if the vehicle is rear wheel drive and front wheel drive. The third one is plot the resultant resistance versus vehicle speed and show the maximum thrust of the vehicle with two types. This is the free body diagram where the tractive effort F and F are acting at the front and rear axle. RA is the aerodynamic resistance acting at a height of HA from the ground level, and RG is the gradient resistance due to the inclination theta. RRR is the rolling resistance at the front and rear tire, and WR is the reaction by the weight of the vehicle. The maximum speed obtained by equating maximum tractive effort F max with total resistance R. So that is equal to F max is equal to R. Then this total resistance R is equal to aerodynamic resistance plus rolling resistance plus gradient resistance. This aerodynamic resistance RA is equal to half rho A CD V square, where rho is the density of air, A is the projected area, C is the aerodynamic drag coefficient, V is the vehicle speed. Rolling resistance is equal to Fr multiplied by W. Then this gradient resistance Rg is equal to W sin theta. Aerodynamic resistance is equal to half rho A CD V square. Assume that density of air is equal to 1.27 kg per meter cube. That is equal to half 1.27 multiplied by 2.32 multiplied by 0.45 multiplied by V square. While simplifying, we get 0.66294 V square RA, equation 1. Then rolling resistance RR is equal to Fr multiplied by weight of the vehicle. Fr they given 0.0136 plus 0.4 multiplied by 10 to the power minus 7 V square, and W is equal to 20,020. While simplifying, we get 272.272 plus 8.008 10 to the power minus 4 V square RR. Gradient resistance Rg is equal to W sin theta. grade is equal to 25%. That is tan theta is equal to 25 by 100. Then theta is equal to tan inverse of 0.25. That is equal to 14.03. Then sin theta is equal to 0.2425. Then W 20,020 multiplied by 0.2425, 4854.85 Newton. This is equation 3. Now the total resistance on level road R is equal to RA plus RR, that is equal to 0.66294 V square plus 272.272 plus 8.008 into 10 to the power minus 4 V square. R is equal to 272.272 plus 0.66374 V square. This is equation. Now the total resistance on 25% grade is apply 1, 2 and 3. In equation, total resistance R is equal to 0.66294 V square plus 272.272 plus 8.008 into 10 to the power minus 4 V square. Then gradient resistance 4854.85. Then upon simplifying, R is equal to 5127.122 plus 0.66374 V square, equation 5. Now, the maximum practical effort that the tire road contact can support is for rear wheel drive Fx max equal to mu W by L into B minus Fr into H whole divided by 1 minus mu H by L. For front wheel drive Fx max is equal to mu W by L multiplied by C plus Fr into H 1 plus mu H by L, where B is the distance from the front axle to the center of gravity, C is the distance from the rear axle to the center of gravity. Now we can simplify mu into W by L is equal to 0.8 multiplied by 20,020 over 2.794 is equal to 5732.283, and mu into H by L is equal to 0.8 multiplied by 0.508 over 2.794, that is equal to 0.145455. Then Fr into H is equal to 0.508 multiplied by 0.0136 plus 0.4 into 10 to the power minus 7 V square, that is equal to 6.9088 10 to the power minus 3 plus 2.032 into 10 to the power minus 8 V square. Now for rear wheel drive Fx max is equal to mu into W by L 5732.283 multiplied by 1.27 minus 6.9088 into 10 to the power minus 3 plus 2.032 into 10 to the power minus 8 V square whole divided by 1 minus 0.145455. While simplifying, we get 8472.808 minus 1.3631 into 10 to the power minus 4 V square. This is equation 6. For front wheel drive, unknown term C is equal to L minus B, that is equal to 2.794 minus 1.27 1.524. Then the Fx max is equal to 5732.283 multiplied by 1.524 plus 6.9088 into 10 to the power minus 3 plus 2.032 into 10 to the power minus 8 V square whole divided by 1 plus 0.145455. Simplifying, we get Fx max is equal to 7661.2 2372 plus 1.0168 into 10 to the power minus 4 v square. This is equation 7. Now the maximum speed of the vehicle for rear wheel drive on level equating tractive force Fx max with resistance on level, that is equation 6 with equation 4, we get 8472.808 minus 1.3631 into 10 to the power minus 4 v square is equal to 272.272 plus 0.66374 v square. While simplifying, we get 0.66387 v square is equal to 8200.536. Then v is equal to 111.14 kilometer per hour. On grade 25%, equating equation 6 with 5, the resistance with grade, that is equal to 8472.808 minus 1.3631 into 10 to the power minus 4 v square is equal to 5127.122 plus 0.66374 v square, that is 0.66387 v square is equal to 3345.684. Then v is equal to 709902, that is equal to 71 kilometer per hour. Now for the front wheel drive on level equating equation 4 with 7, that is 7661.2372 plus 1.01688 into 10 to the power minus 4 v square is equal to 272.272 plus 0.66374 v square. Then 0.663638 v square is equal to 7388.96. Then v is equal to 105.509 kilometer per hour. Then front wheel drive with grade 25% is equating equation 7 with 5. We get 7661.2372 plus 1.01688 into 10 to the power minus 4 v square is equal to 5127.122 plus 0.66374 v square. 0.663638 v square is equal to 2534.1152. Then v is equal to 61.794 kilometer per hour. Now the answer are: maximum speed on rear wheel drive at 0% grade is equal to 111.14 kilometer per hour. At 25% grade is 70.992 kilometer per hour. For front wheel drive at 0% grade is equal to 105.509 kilometer per hour, and at 25% grade is equal to 61.994 kilometer per hour. The third question is: plot the resultant resistance versus the vehicle speed and show the maximum thrust of the vehicle with two types. Now we have to make a computer program. The speed with us having an increment of 20 kilometer per hour, and then resistance, the total resistance on level and at a 25% of grade, that is theta is equal to 14.03, and this maximum tractive effort available for the tire road contact patch. Then this data, if you are plotting this curve, resistance at the grade 0%, this curve is the resistance at the grade 25%. The maximum tractive effort available for the rear wheel drive is indicated in the green line. The maximum tractive effort available for the front wheel drive is indicated here. The line crossing the resistance with the tractive effort here is 71, here is 62 km per hour for the front and the rear wheel drive. Here is 105 km per hour and 111 km power for the front and the rear wheel drive. The maximum thrust available with respect to vehicle speed is the gap between the tractive effort available and the resistance. This much for in the case of rear wheel drive, this much in the case of front wheel drive. So in this exercise, there is one contradictory thing is this aerodynamic resistance equal to half rho a v square multiplied by cd. This v is in meter per second. However, we are not calculating this aerodynamic resistance, just we are substituting v in terms of kilometer per hour. Since the rolling resistance coefficient fr, the v is given as kilometer per hour, particularly they mentioned it, so you have to take this v is in the kilometer per hour.
Subscribe to our channel, like if you're satisfied, and share because it may useful to someone.